So it is the fast moving things will be clouds. So we hope we don't get clouds right now, and we'll enjoy the show completely. So yeah, Niruj, if you can repeat your question. Actually, there was an echo going on, so I couldn't hear your question.
Yeah, I wanted to ask you what has been the history of eclipse studies in IIA historically? How have eclipses been important in understanding about understanding the sun?
Actually, yeah, if you can hear me, so uh, the eclipse study is during the eclipse we have studied the sun from quite a long time. So here in Kodaikanal, or even before when it was Madras Observatory, it was during the eclipse that in IIA of course was not yet formed. It was not named as Indian Institute of Astrophysics. It was named as Madras Observatory. I think we were able to detect the helium during the eclipse itself. So the presence of helium element in the sun was detected during the solar eclipse. I think that is one of the major contributions of or the legacy of Indian Institute of Astrophysics when it was called as the Madras Observatory. So yeah, that is one of the major studies which was done here at Madras Observatory.
Thanks, Ramya. Yes, indeed. For many of you who may not know, the element helium is named after the sun. Helios means sun in Greek. And helium was discovered in the spectrum of the eclipsed sun from India in 1868 during a total solar eclipse on 18th August. Norman Pogson, who was the director of the Madras Observatory at that time, was in Machilipatnam, and Pierre Janssen from France was in Guntur, both in Andhra Pradesh, and it was them who discovered the new spectral line in during the eclipse, which Pogson then attributed to a new element called helium. And therefore, eclipse not only is that an important discovery from a solar eclipse, it also has a very interesting Indian connection. And of course, we all know about the other very important discovery made during eclipse, which is that of confirming Einstein's general theory of relativity in 1919 by Arthur Eddington, when he discovered that the light from the stars behind the sun were indeed gravitational lens, the way Einstein's theory predicted. Vagish, can I ask you to tell us a little bit about what would you see if this eclipse was total, and why would a corona be important to study?
Okay, yeah. So actually, the history of eclipse goes back to many thousands of years. In fact, there are many historical texts in India which have already explained about the total solar eclipse. In fact, the oldest document in India, actually, Rig Veda have also taught about means how total solar eclipse can happen, but of course in a form of a story. More scientific phenomena, this like it is observed like a more scientific phenomena in the very after actually in the time of Aryabhat, if we read his books, there is a discussion of how transit of moon between the earth and sun can actually cause total solar eclipse. And this phenomena has been very important for solar astronomers because they try to look at the corona, outer atmosphere of the sun, which is actually billions times fainter than our Earth atmosphere. So it cannot be actually seen if there is no occultation of the disk of the sun. And this astronomical phenomena allow us to observe the faint corona at the time of total solar eclipse, and then we can study what are the dynamics of the outer solar atmosphere. So in this way, we have some understanding how the energy from the deep interior of the sun can propagate and even perturb the outer atmosphere of the sun. And such total solar eclipses have allowed us, many parts of the world, people have taken tour to observe total solar eclipse, and they have derived scientific conclusion about the outer atmosphere of the sun and the phenomena happening there.
Thanks, Vagish. Now I think all of us can see that the eclipse has started in Hanle as well. Leh, of course, is the capital of Ladakh. Hanle is around 6 hours drive from Leh in Ladakh. where we have our Indian Astronomical Observatory. Can I ask the control center to put my video on? I have in front of me a spoon, which is what you use in your kitchen for frying stuff, right? And the holes in the spoon is what I mean. So if you hold such a spoon against the sun and look at the image through the holes on the floor or the wall, you will start seeing the eclipse sun when the eclipse is visible for your region. This is a very, very easy pinhole camera for you to.
Can you once more, because I think the feed came a little later. Just repeat once quickly.
Yeah. So this is what I mean. This is the spoon I think all of us have in our kitchens, and the holes we have here are a few millimeters big. So if you hold it against the sun and look at the image on the wall, once the eclipse starts for your location, you can start seeing small images of the eclipse sun yourself. And this is like a very, very safe, very, very easy, well, free method of seeing the eclipse. We also have a lot of comments about whether we can eat during an eclipse, or we can go out during an eclipse. And the answer, of course, is yes. You can do whatever you want to do in the eclipse, except looking at the sun directly, the naked eyes or through a telescope. Feel free to eat and drink and go outside and play and look at the telescope. Look at the eclipse through eclipse glasses safely and enjoy it. The few questions here which I'll just run through very quickly. Yes, the IIO Hanle is run by us. The IIO stands for Indian Astronomical Observatory. It's at a height of 4,500 meters in Hanle. It hosts two optical telescopes, the Himalayan Chandra telescope, which is 2 meters wide, the Growth 0.7 centimeter telescope, and in the base camp, we have two Cherenkov telescopes to observe gamma rays indirectly. One is called Hagar, which we operate with the Tata Institute of Fundamental Research, and the other is called MACE, which is the second largest Cherenkov telescope in the world, which is operated by BART at our observatory. We also have observatories in Kavalur, in Tamil Nadu, which is near Vaniambadi or Vellore. We have a radio observatory in Gauribidanur. We have.
Niruj, I am Ebi speaking here.
Yes.
And a huge crowd of people are waiting in Kodaikanal to watch the solar eclipse. Thank you.
Yeah, thanks, Ebi. We have the Kodaikanal Solar Observatory, which is more than 100 years old, which is where Ebi is speaking from now. We have also engineering facility, a state-of-the-art facility in Hoskote, outside Bangalore, and of course we have Ladakh. Can I ask Ebi to turn his camera on? Just show us the crowd there. So if you can put Ebi's camera, which is I think called display.
Niruj, we are waiting here and we are watching your display.
Would you be able to show us the
Kodaikanal is very cloudy. As we already predicted, Kodaikanal is cloudy. We cannot see it. And morning we have taken some pictures.
Ebri sir, would you be able to
from the historical 6-inch
telescope?
We have taken it.
Okay. Maybe I could request Ebri sir from Kodaikanal Solar Observatory to send us the picture they took of the sun with their telescope on WhatsApp, and we will show it to you now.
Okay, I will send it to you.
Thank you. Okay. Now we'll go back to the eclipse. As you can see, there are a lot of clouds in Leh, but the Hanle side seems to be very, very clear. And you can see the moon eating into the eclipse.
Why can't we see on a bigger display this thing, where IIA eclipse control room is there?
We are trying to show both Leh and Hanle at the same time because the clouds in Leh keep coming and going.
Oh, yes.
On YouTube, you can see just the Leh and Hanle feed.
Oh, okay.
Okay. Now I would like to get Aratrika in and Ramya, if you can, and tell us a little bit about this whole eclipse eating campaign we are running.
Hi. Niraj, you can see people around.
Hello.
Hi. Niraj, you can see people.
Aratrika,
Am I
please go
audible?
ahead.
Yeah. Hi. There's this popular, like very pervasive myth that, and we are also seeing it in the chat box very frequently, that in the YouTube chat box, that people are not supposed to eat during eclipse. Or maybe there's another thing widely believed is that people are not supposed to cook also during eclipse. And if you have any leftover food from maybe from some time before the eclipse, you are supposed to put holy basil leaves into it and sort of preserve it. That sort of all these different types of myths, of all sort of varieties are practiced almost ubiquitously all across India. So we again emphasize that there's no restriction in eating or cooking food during eclipse. Eclipse is a completely natural phenomenon that does not in any way affect the food when you have it or cook it while the eclipse is going on. So feel free to eat, and also share your selfies with us. Take a selfie with the image of the eclipsing sun in the background with you eating food, and share it with us on Twitter or Facebook or Instagram or any place you feel like, with the hashtag eclipse eating. We can also find out about it in the reels that we share in the process leading to this eclipse on our Instagram and Twitter and YouTube pages. So yeah, eclipse eating and happy eating during the eclipse. Thanks.
Thank you, Aratrika. Can I ask Crispin to turn his video on, but not his mic?
I'm showing that I'm drinking juice. So this is my hashtag eclipse eating.
Okay, there is a question from Chirag Chawla. It says, why can't we look at the sun directly during an eclipse, but we can do so on normal days? That is not true. Please do not look at the sun directly at any time through naked eyes, through binoculars, through a lens, through a telescope, anything at all. It's very, very dangerous for your eyes to look at the sun directly during an eclipse or during normal times. There's somebody else who said that he has Polaroid glasses with UV protection. It may not be safe to use because the required amount of UV needs to be cut out, and therefore eclipse glasses are calibrated and they guarantee to cut out the required amount of ultraviolet and visible. Therefore, we would recommend that you only use eclipse glasses to look at the sun directly during the eclipse. Another question says, if sun emits radiation always, why is it said that it's more harmful during a solar eclipse? Banyal, do you want to answer that?
Yes, sun emits the radiation all the time, and so if you look directly, it's going to damage your eyes, no matter whether it is eclipse or not. Now, during eclipse, what happens is, especially when it is a total solar eclipse, when the sun's disk is completely blocked by the moon, it's literally close to dark, and when we are looking directly, if at all, we shouldn't do that, but if somebody is looking directly at the sun, so what happens is, in the darkness, the pupil dilates, it becomes bigger, and suddenly when the moon moves slightly, there is a sudden gush of light, and eye cannot adjust immediately. So that can be a little bit more harmful, because eye pupil is wide open and your eyes are exposed to a lot of photons. So that in that sense, it can be a little bit more harmful or dangerous if you're not careful. So no way you should look directly at the sun, whether it is total solar eclipse or partial solar eclipse.
Thank you, Banyar. I see that Vagish Mishra is with us. We're looking at the sun now during an eclipse, and that's fascinating. Now, an eclipse is one of the most beautiful sights you can see in the sky. But the sun is also an object of study for astronomers for various reasons, right? And we've been looking at the sun from the Earth, of course, from Kodaikanal and other places for many, many decades in India. But then we're going to something very, very interesting next year. We are going to be launching a space mission to the L1 position in our orbit, which is meant to just look at the sun, right? It's called Aditya, and it's going to be India's first solar space mission. So, Vakish, do you want to tell us why that's something all of you are very excited by?
Yeah, so actually, as you pointed out that India has planned a mission called Aditya L1, which is actually being designed and developed by Indian Space Research Organization, and of course with participation with other research institutions. And this mission will be soon inserted in the coming few months in the halo orbit around the L1 point between the Sun and Earth. And this mission is actually being planned to study the solar atmosphere. There is something called solar magnetic storms and its impact on the environment around the Earth. Actually, Sun also ejects a lot of plasma, huge plasma, that actually comes in the heliosphere around the distance between the Sun and Earth, and that can, once reach to the Earth, it can disturb the Earth's magnetic field. And therefore, such disturbances to Earth's magnetic field can lead to a lot of perturbation. It can lead to space weather events that can lead to GPS failure, error in our navigation, communication, and it can cause complete blackouts. There are some events in the history where solar storms have led to very much billions of dollars of loss in different countries. So therefore, India has planned this mission to understand the sun as a star in a very detailed way. And once we understand the sun, we are more closer to understand the cosmos, which is full of stars. So it is a first step to understand the star in depth. And this mission actually will study several things like coronal heating, solar wind acceleration, and it will continuously observe the photosphere, chromosphere, different actually atmosphere of the sun. So we can say that India had planned the first dedicated Indian mission to observe the sun. It will be probably launched in the coming February or March by this PSLV launch vehicle. Yeah.
Thanks, Vagish. As you can see, it's extremely cloudy in Leh, but thankfully, Hanle it's completely clear, and therefore we're having a wonderful view of the solar eclipse from Hanle. And thanks for the control center for zooming in when required to the correct stream. You can see that a good fraction of the sun is already eclipsed. Around half the sun will be eclipsed just before sunset, and we are very, very happy that all of you are able to join us. I see that YouTube has more than 4,500 people, and we welcome all of you and very happy that you are here with us. There was a question as to why each of these streams show the moon shadow at different directions, and that's an excellent question. That is because the latitudes are different for each location, and as you move in latitude, the direction in which the moon will eat into the sun will change. Okay. There have been many, many questions repeatedly about can we eat, can we drink, and so on. And that, just to repeat, yes, you can eat during an eclipse. Yes, you can drink during an eclipse. Yes, you can go out during an eclipse. You can do all of that. I would now invite more questions on YouTube chat on the eclipse and about the sun, and we will take them as you post them. Yeah, we'll just give you a couple of minutes to type in more questions, and then we'll take them. Yeah, there's a question from Jayant Malse, which says he's asking, how do rays of the sun deflect differently during the eclipse? Do they give out different rays after hitting the moon's surface? Banyal, do you want to respond to this since you mentioned this briefly before?
So question is, how do the rays gets deflected from the sun. From the moon.
During eclipse. Yes.
Yeah. So during the eclipse, it's not that moon is deflecting in a special way. It's always when you see moon in the sky, not during the eclipse, but otherwise, the moon reflects some of the sunlight that falls on it. So during eclipse, actually it is not going to reflect because it's the darker side of the moon which is towards us. So if at all any light which comes to us, it would be only close to the edge of the moon, slightly reflected from the edges and so on. But there is no special way that the rays are getting deflected to Earth because it's an eclipse. So that doesn't really happen. That's correct, right?
Yes, thanks, Apapanya. We're very happy to have the director of our institute join us, Professor Annapurni Subramaniam. I would like her to introduce herself to everybody and also answer this question we just got, saying why do we not get an eclipse every new moon or full?
Yeah, so hello everyone, and happy to join us online to view this wonderful event, nature's basically magic. Basically, it's nature's magic to tell us how an eclipse can happen. And today is a solar eclipse. The question is, today is basically like a new moon day where we have the solar eclipse happening. But we do not have the eclipse happening on every new moon day. The question is, why do we have it only on certain new moon days? So I can basically give you, with respect to a very, very simple explanation, using my bangles. Can you, yeah. So the bangles is like if you have an orbit which is like this, and you also have the moon going around the Earth in same orbit, then it is aligned. So every point, every time it comes between the sun and us, then it will be blocked. But actually the orbit is slightly misaligned. So I'm just exaggerating. So it is basically like, it is misaligned by 5 degrees. So if you have a misaligned, I'm not able to hold it, yeah. So if it is misaligned by 5 degrees, what happens is it cannot come in the same line of sight. So only when the line of sight matches, that is when the opposite ends, 1 and 2. 1 and 2 diametrically opposite ends where the Earth and the Moon come line of sight in the Sun. So because of this orbit, only you would have guessed by now, 2 times a year this alignment works. And because of this, the eclipse, you can predict the next one. Now, can someone write when will be the next possible eclipse if it is happening in October? When can it be? It can be in next 1 year or next 6 months. It's up to you.
Thank you. Since we are very happy to have the director here, do you also want to tell us a little bit about how the history of IIA is linked with eclipses? What we've been having expeditions to study the total solar eclipse for many decades, right? So tell us a little bit about that.
Yeah.
And here's some biscuits for you to eat.
Oh, thank you.
During the eclipse.
During the eclipse, right? Yeah, I would like to have some water, but yeah, the biscuit is fine. So I just had my coffee, so it has got nothing to do with this. You can eat. Just that I'm blocking the let's say I'm blocking the painting behind me, right? It's just what's happening. The painting has got nothing to do. Painting doesn't even know it is getting blocked. It's just your viewpoint. I'm blocking the painting. It's just the line of sight projection. So just because the moon comes between us and the sun does not mean that anything odd is happening. So you can definitely eat and go on with your life. Except you should not look at the sun. That's the only precaution you should do. That's all. Nothing else. Why? Because there is an excess light, and then it's like you go into a dark room and suddenly switch on a floodlight. Eyes will get really, your eyes collecting a lot of light, and suddenly the lot of light enters in. So that is the only reason, nothing else. It's not that anything is emitting more. But IIA has a long trek. Why do you want to study eclipse? Because that's the time when you see the corona of the sun, and that is very, very faint. It's like looking at a what do you call the flickering small insects in front of a floodlight. So you have to study it when you block the sunlight of the disk. Now that is when you have to study the corona, and you cannot do it artificially. So you go towards places where you can have total solar eclipse and set up experiments. IIA has more than 120 years of studying the sun. The heritage of IIA is studying the sun for more than 120 years. So we study not only the sun's phenomena, the variability, the sun, why it is throwing out material like coronal mass ejections, etc., and the magnetic fields. And since we are living with a star, we should know the star and then when it is safe for us and the same for the living organisms here, etc. So understanding the corona of the sun and how the matter is ejected is also very important. That is what is studied in eclipse. And I think we'll be launching the mission to study the sun in particular, that is called the Aditya L1 mission. And the institute is actually built an instrument which can actually permanently block the light. That means a permanent eclipse, so that you can always see the corona and you can always see if a matter is ejected from the sun and goes into the corona, you can actually track it. So that is called the emission line coronagraph, and that is what the institute has built, and that will be launched soon in the mission, which is going to be placed to the L1 point. So if you're interested, a lot more to read up, understanding the sun, understanding what is the Lagrange point, etc., etc. And we will come more with the details of this mission and what we plan to study in another episode. Yeah.
So as soon as they've seen you come online, there have been a lot of questions about career options in IIA. So I request you and the Dean Ishwar to kind of say briefly what are the opportunities for people with an engineering degree and with a science degree.
Yeah, so I can just talk about a few things. One is you need instruments to pick pictures, and you need, like the mission, I think someone has just written about James Webb telescope, right? So it's producing excellent pictures. Now, to get the telescope built, to have this mirrors polished, coated, all these engineering components in place, and the unfolding, folding, etc., and then you put it on a mission and send it, you need a huge number of people working on it, and the team include large number of engineers, large number of planners, you need managers, you need even lawyers, because it is a collaboration between various space agencies like the NASA, the European Space Agency, and the Canadian Space Agency. You need to have agreements written down, etc., etc. So career options are wide, and definitely if you want to do law, and the law is used to promote science between various countries, it's really nice. So actually the job opportunities are like, we run several observatories. We run ground telescopes. We also have a space telescope, one in orbit. Now, next one will go soon. We have a team of scientists who do science. We also have a good number of engineers who not only build instruments, but also support the operations and maintenance and working of these telescopes. These telescopes are working and producing pictures because of large number of expert engineering team involved. What kind of engineering? Optical engineering, electronics, communication, computer. So all sorts of engineering are involved there. And in IIA, we do have teams like this. And of course, communication, science communication, documentation, everything, library, all these support are part of any organization for that matter. So I hope I answered this question. So mega projects, that's another place where India has a lot of collaborations, international collaborations. They also have a lot of engineers, etc. Maybe Ishwar can say a few words on that.
Thank you. Ishwar, would you like to add something to it? Ishwar, if you're there, would you like to add something to that? Okay, we'll get him.
Yeah, we can see the lake clearing, I guess.
Yeah, it's
right?
beautiful.
It's beautiful.
So then let's go to a few more questions. We have some very interesting questions since then. There's a question which says, why can't the shadow of Mercury and Venus fall on Earth? I think that's an excellent question. The answer is yes, it does. And I'll ask Banyal to say something about that.
Okay, to understand how the shadow that we fall on Earth because of the solar eclipse, when moon comes in between the sun and earth. So remember, moon is 400 times smaller than sun, but sun is about 400 times away from moon. So when we look at both bodies in the sky, both objects in the sky, their size look almost same. Their apparent or angular size is almost same, right? Which means that during the eclipse, the moon can block the entire disk of the sun. So as a result, that's when we get the complete darkness. Now, when we take Mercury or Venus, yes, they can also pass in front of the solar disk, but they are at a vast distance from Earth. So their angular size from the Earth is very, very tiny. And as a result, the shadow, so-called shadow caused by them, or as seen from the Earth, would be very, very small. But it's the fact that, yes, Venus and Mercury transit also happen. Transit is nothing but eclipse, just happening at a very, very small scale. Small scale because the angular size of the Venus and the Mercury, as seen from Earth, are very small, let us say, compared to the moon. So another thing is that, again, the Earth and rest of the planets are revolving sun in their respective orbits, and these orbits are not all in one plane. They are not exactly in one plane. Each of the planets have a tilt, the orbital tilt of each planet with respect to the other planets. So it's for the same reason that we do not see the transit of Venus or transit of Mercury every year, but only when there are the configurations are appropriate and suitable. For the same reason that we see the transit, we see the solar eclipse rarely, because it's only on certain occasions that moon, the orbit of the moon and the Earth around the sun, orbit of the moon around the Earth and orbit of the Earth around the sun, they happen to align only rarely. So total solar eclipses are on an average observed probably once in 18 months somewhere on Earth. So that's why they are rare. Whereas the partial eclipses are much more common. They may not occur at one place all the time, but at somewhere or other on Earth, you would definitely see them more frequently, the partial eclipse.
Thank you, Panya. So the next partial solar eclipse that will be seen in India is on 2nd August 2027, so it's quite a few years to come. And that will be seen across South India. The next total solar eclipse will be seen on 20th March 2034, and the path of totality will cross Punjab, Himachal, Haryana, and so on. So, you can mark your calendars right now if you wish, and we'll see you there, of course. A couple of questions which are coming, which I want to take. There's a very interesting question which says, if we are on the moon, shall we also have an eclipse because of Earth's shadow? By Koka Vijay. I think it's a wonderful question. Yes, and so if our shadow falls on the moon, we experience it as a lunar eclipse, right? Where the moon gets covered by the Earth's shadow. If you're on the moon at that time, you would experience it as a solar eclipse. And I think that, and so if you're on any object in the solar system, you will have some eclipse. That is beautiful. For example, there's a wonderful video online taken from the Perseverance rover on Mars, where they have seen, I think, Deimos, the moon of Mars, eclipse the sun, right? And so now we started seeing eclipses from other planets in the solar system, which is I think very, very beautiful. There's also been a wonderful set of images of the total solar eclipse shadow on the Earth's surface, as taken from the International Space Station. I would encourage you all to Google it. There is beautiful, amazing images. Now, I think, thankfully, the clouds are parted in Leh. So now we have beautiful images from Leh and Hanle of an eclipsed sun. And you can see that it's nearing around 55%, which is the maximum. And at 5:12, the eclipse will be seen in Bangalore, at which point we will try and relay a live feed from Bangalore from the terrace here as well. I see that Piyali Chatterjee has joined us. Piyali Chatterjee is a faculty at our institute, and she is also a solar astronomer. So we had Vagish Mishra tell us a little bit about the sun and the corona and why it's important that we're launching Aditya. I'll ask Piyali to come in and say a little bit about what are the other interesting things about the sun which people might not know, and how we can maybe connect that with things around us in our houses or something in our laboratory. Piyali, please.
Can you hear me? Can you hear me?
Yes, Piyali, please go ahead.
Yeah. So, Neeraj, can you please repeat the question for me?
Piyali, if you can tell us a little bit about what are the other really intriguing and surprising things about the sun, including things which might have relevance to paint and things like that.
Okay, yeah. Hello, everyone who has joined us today on this live program from IIA, which is being curated by Neeraj. I work mainly on the solar atmosphere as well as the interior magnetic fields of the sun. So one of the interesting problems is the sunspot cycle. As you know that sunspots appear and disappear on the surface of the sun with a periodicity of 11 years. So one of the challenging problems in solar physics is to reproduce this phenomena using mathematical and numerical models. And we have been successful, or the community has been successful to some extent, but I would say there are a lot more things to be done in this area, especially to explain the irregularities. I mean, irregularities in the sunspot cycle. So, for example, why one sunspot cycle is stronger than the other, and so on and so forth. Now, if you come out from the atmosphere into the atmosphere of the sun, you know that sun has different layers, like just layers of an onion, for example. And so you have a core, a radiative zone, a convection zone, and then you have a photosphere, and then a chromosphere, transition region, corona. So these are all technical terms, but these are all different layers of the solar atmosphere. So yet another grand challenge problems in solar physics, or in stellar physics rather, is to find out why the corona of a sun or a star is much more hotter than the surface of the star itself. So, for example, in the sun, the surface temperature is about 5,800 degrees centigrade. But as you go up into the corona, away from the source of the heat and light, the temperature actually increases to 1,000,000 degrees. Now the community does not have any definite answer to why such a thing happens. There are, of course, theories. So sorry about the background noise. I'm actually on a highway now. So I was saying that there are theories. There are two competing theories, but the community hasn't agreed upon what exactly is happening. So there is this heating due to dissipation of waves. So you know there are these waves which, like if you stand on the beach on a nice day and you see waves approaching the shore. And as they approach the shore, they break, right? The waves dissipate away. You don't see the waves anymore. They crash. So one of the theories is that these crashing waves in the sun, they dissipate and they convert their energy to heat. Now, the second competing theory is something which only happens for magnetic fields. So you know that sun and other stars, they possess a very strong magnetic field. And these magnetic fields are not like, dipole of your normal bar magnet in the laboratory. They are much more complicated. So they have a lot of twists and braids and a lot of these turbulent features in them, because of which the magnetic field lines, they do what is known as a reconnection. So because of this reconnection, there's a lot of heat generated. Like that happens in your electrical circuits, for example, the I square R losses. So in layman's term, these are like I square R losses. And these also give rise to heat. So there is no consensus yet in the community now about which mechanism dominates in which part of the sun. So that is one of the grand challenge problems in solar physics. Of course, there are more, but right now I can think of two which can be explained in a simple manner.
Thank you, Piali. So I think we heard quite a bit from Piali and Vagish about the fact that the sun is still a object of study. We still do not understand everything about the sun, and therefore there are solar astronomers studying every aspect of the sun using ground-based telescopes and the upcoming space mission called Aditya, as well as simulations and theoretical studies and observations and so on. So it's still a very, very active field of study. And we hope that some of you here today will become solar astronomers because of today's eclipse. So there's one question I wanted to take. Before that, there are many more comments about eating and drinking during the eclipse. So we would like to repeat, yes, you can eat during the eclipse, you can drink during the eclipse. It's absolutely no harm caused. Yeah, it's basically eclipse basically a play of shadows. The moon is coming between us and the sun. It could well have been your hand, it could have been a building, it could have been anything else. It's no different from you hiding behind the shadow of a building during a hot afternoon. And therefore, eclipses have no harmful effects on us at all. The sun and the moon doesn't really care much for our lives, really. And the only thing we have to worry about is do not look at the sun directly with your naked eyes or through a telescope or a pair of binoculars or anything at all. You will damage your eyes, so please do not do that. Okay. There was one question which said, how did our ancestors know how to predict eclipses? That's an excellent question. So eclipses have always been things which scared people, right? If you do not know how an eclipse is caused, the sun disappearing suddenly or the moon disappearing suddenly can be very, very scary. And therefore, every culture was scared of it and had myths and had stories to explain it. Right? So most cultures had some kind of a demon or an animal eating the sun or the moon during an eclipse. And then you had to force it to go away by beating drums or shouting or doing some rituals and so on. But then long back, around 3,000 years ago, people, especially in Mesopotamia, noticed that there were some patterns to when the eclipses were caused. The cultures which were very, very scared of eclipses, which were basically the Babylonians or the Chinese, maintained meticulous records of eclipses because they were scared of it, right? And they started noticing some patterns in the sense that they said, okay, if I have an eclipse and another eclipse of some type, then they would repeat after 18 years and so on and so forth, right? So these are called the Saros cycles. And so purely arithmetically, people found out various patterns of repetition in the eclipse when the eclipse occurs, right? And they used this to predict eclipses for a long time. And these were kind of reasonably accurate for a few hundred years, right? But then by the time, 3rd, 4th century, CE rolled over, including, Aryabhatta in India, and of course in China and Babylonia and Egypt and so on, people had started observing the motion of the sun, the moon, the planets a bit more carefully. They started measuring their positions and they started trying to predict their motions as well, right? This was basically like a phenomenological model, right? So you fit circles, you fit epicycles and so on. You fit certain parameters and then you try and predict them, where they would be the next month or next week. And if they differed from where you thought they would be, you then refine your methodology, refine your tables, and so on to make it more and more accurate. And in India, of course, we had a wonderful tradition of this from Aryabhatta to Varamira to Bhaskara to Lalla and so on, right? Up to the Kerala School of Mathematics in the 1800s, which included Nilakanta Somayaji, who came up with what we now know as the Tycho Brahe model a few decades before Tycho Brahe did in Europe, right? But then if you ask any of these astronomers in India, China, Egypt, anywhere, how did this happen? Why are they moving the way they did? We did not know that, right? That had to wait till we had a dynamical theory which came from Newton, right? So once Newton came up with his gravitational theory as well as the laws of motion, we could then understand why planets and the sun and the moon and the earth move the way they do. And then you could predict eclipses with much more accuracy, which is what we did. So in some sense, these are 3 stages of prediction, historically speaking. First, we look at patterns, like 3,000 years ago, and with patterns of eclipse occurrence, you predict where it should occur next. Then you started fitting formulae through the motion of the sun, the moon, and the planets, and then use that to predict what happens later. And then after Newton and Halley and so on, we had dynamical theories where you could put in more and more details and perturbations and predict things more and more accurately. So I hope that answers that question. If you look at the feed from Hanle, you can now see it's almost maximum eclipse. It's half the sun is covered. The little bit of dark things at the bottom in the Hanle feed is the mountain below, which is going to sink very soon. And in Leh, though there are clouds, you can still see the eclipse sun very, very beautifully. So hello everybody. I'd like to welcome another famous astronomer, Professor Siraj Hassan, who's the ex-director of IIA, and he's a very, very well-known solar astronomer from across the world. He's been a part of the solar astronomy journey of IIA since the very beginning. And I would ask you to just say hello and tell us a little bit about what the kind of things which interest him and excite him about the sun and about this eclipse in particular.
Well, first of all, greetings to everybody. I was just telling the director that I've been to about, I've witnessed at least six, I've been to 6 eclipse expeditions and all 6 have been successful. So that's been really a big bonus. As far as my interest in the sun is concerned, it's been looking at trying to understand what magnetic fields do in the solar atmosphere. And so we've, in most of the eclipse expeditions, we've tried to look for waves, signature waves in the solar atmosphere. And I must say that the papers that have come out of these expeditions have convinced, I think, the community that such waves do indeed exist. We were looking at short wave, several seconds to up to a minute or so, and I think, well, wow. Yeah.
The Hanle sun is setting.
Yeah, that's amazing. Well, I'm not going to go on too long. I'll give it back to Niru.
Maybe I can ask you to say something about one more solar experiment we haven't talked about yet, which is to build a really large solar telescope in India, which you have been a really integral part of, the NLSC.
Well, yes, the National Large Solar Telescope Program.
Sorry to interrupt, Neeraj, I'm closing. Yes, it's below the mountain.
Okay, so this is a message from Hanle saying that the sun is set for them. So let's all thank people in Hanle. Crispin, do you want to turn your video on? Yeah, so there's Crispin and his colleagues at Hanle. The sun has set in Hanle now. Can you bring everybody in? We'd like to see all of you and say hello. Everybody in Hanle. Hanle, to remind you all, is a site of our observatory in Ladakh, which is 4,500 meters high. We have now in the camera people from IIA, as well as whom we call the Hanle Dark Sky Reserve ambassadors. These are young people from the nearby villages who are going to become the astrotourism guides for the upcoming Hanle Dark Sky Reserve. And they're very, very happy that they're able to join us here. So, hello everybody. Thanks a lot for your feed from Hanle. We will continue with the Leh feed now, but on behalf of everybody watching us from around the world, we'd like to thank everybody at Hanle for the delightful live stream of the eclipse you've been giving us so far. Now we'll cut back to Siraj Hassan and we just let him conclude about the NLSC.
Okay, yes. So as I was saying, the project started about more than a decade ago, and we were able to identify a superb site on the shores of Pangong Lake in Mira. And the project is now reached a very mature stage. It is now with the Department of Science and Technology, and we are hopeful that soon means in about less than a year or so, this project will get the final go-ahead. As far as the team is concerned, they are absolutely ready. All the design and everything has been worked out. The experiments, the scientific team, everything is now in place, and I think it's just waiting for the final go-ahead. Okay, Neeraj, back to you. Okay, thank you.
Thank you,
Everybody.
Thanks for dropping in. And I think he's on his way upstairs to look at the eclipse through the eclipse glasses himself. Because in Bangalore, fortunately, the sky actually is clear, which is quite a rare occurrence. So now I'll ask Banya to take a couple more questions from YouTube chat.
So, yes, please put your questions in the YouTube chat box and we can take them. So, one thing I can tell you about the eclipse is in general, how eclipses move on the Earth. Remember, Earth rotates from west to east at a speed of 28 km per hour at the equator. And the moon is also orbiting the Earth from west to east about 28 km per minute. And moon is also orbiting Earth west to east about 61 km per minute. Okay, so during eclipse, moon's shadow also moves from east to west with a speed which is difference between these two, that is 68 minus 28, which is 33 km per minute across the Earth's map, right? So that is roughly how this shadow of the moon moves on the surface of the Earth, and that shadow is basically called the track of the eclipse. And in most favorable circumstances, when the total solar eclipse occurs, the track can be up to 267 kilometers wide, and the totality can last as long as 7 minutes. Right? So that happens in a very, very rare circumstances. And the partial eclipse can be seen from a large area on the Earth's surface, as large as 6,400 kilometers wide and so on. Typically the totality, the band of the totality could be 100 to 160 kilometers when there is a total solar eclipse. And the shadow can sweep an area of Earth's surface about 16,000 kilometers. Right? So if there is an eclipse, as I said, the shadow moves to different part of the Earth, and from start to end, it could be as long as 16,000 kilometers. And total solar eclipses are rare events, although they occur somewhere on Earth every 18 months on average. It's estimated that they reoccur at a given place only once every 360 to 410 years on an average. So that's like if you are seeing a total solar eclipse at one place, that's only going to be a one lifetime event. And again, I want to reiterate that these eclipses are basically the geometrical effect, and there is nothing supernatural or divine about it. And whatever damage or harm people talk about, that's so. Well, you can see from Leh Ladakh already a very small part of the sun is now seen. Partly it is blocked by moon and partly by the foreground mountains. So this is again a very rare picture that you would see for next couple of minutes or maybe less, because you can see it is shrinking very fast, and in a minute or so the sun would set in Leh. So these are the last couple of seconds that would be visible before the sun sets and this spectacle come to close. Yes, the last part. So we can see that there's only very small portion which is almost now gone now. So that concludes the eclipse from the Leh Ladakh. And we are trying to get the feed from Bangalore because sun is yet to set, and we already had some eclipse going on here, right?
Yes, that's true. So the eclipse started in Bangalore only a few minutes ago, and we're trying to get a feed from upstairs, literally. But as you can see, the eclipse is, once the eclipse sets from north, it keeps the shadow keeps traveling downwards and southwards.
Yes.
So while we're getting the Bangalore link, you please continue posting questions, and we will try and answer them while we're waiting. Okay. So how do you visit Leh and Hanle is a question. You'll have to write to us, go on our website, and you can fill up a form for that. Why should we not eat during the eclipse? You can. Shyam's asking, can I watch the eclipse with bare eyes? Please do not do so. It's not safe for your eyes to look at the sun directly. You have to use eclipse glasses or any projection method.
So there is a question on gravitational lensing during eclipse. So remember Einstein's general theory of relativity, which predicts that if there is a heavy massive object in the foreground of a star, then that object is going to bend the starlight. Now that was the theory, and in order to prove that, to give experimental proof for that theory, Arthur Eddington in 1919 eclipse expedition planned an experiment to test the theory. So that happened to be the total solar eclipse day in 1919, and when the total solar eclipse happened, they took several images of the sky and with the background stars. And when you take the same images of the same part of the sky 6 months later, you would see that position of the stars in these two images was different. So there was a slight shift in the position of the stars, and that shift was attributed to the gravitational bending which the sun caused to the background star, or the light coming from the background stars. So this is how the lensing happens when you have a massive object in the foreground and the light is coming from a source which is in the background. It's a myth. So I'm also looking at the questions, and I would respond if there is any question. So there's a question whether Earth is the only planet which can experience the solar eclipse. That's not quite correct. Remember, eclipse is happening when something is coming in between the Earth and the sun. Now that can be true for any planet. So if there is some other object which comes in between the other planet and the sun, that would cause the eclipse at that planet, right? So some of the moons of Jupiter, as well as Saturn, and maybe also of the Mars, can have the similar configurations which may cause the eclipse or solar eclipse for those planets. So it's not the phenomena which is only observed on Earth, but it could be widely observed on outer planets which are outside the orbit of Earth. Okay. Yeah, if you have any more questions, you please feel free to post it on the chat box in YouTube. While we are trying to get you feed from Bangalore, the eclipse has already started here. Sun has not sun. Our both feeds that were really very successful from IIA Leh as well as Hanle, we have seen the spectacular eclipse happening there. And right now the sun has already set. So the feed from those two places has stopped. And we will try to have it from here, from Bangalore in a short while if we are able to do that. What happens if Earth stood motionless and sun and moon rotate about it? No, that's a hypothetical question. Sun is the massive body, and if you look at any other objects in our universe, it's always the lighter bodies which go around the massive bodies. And by the way, nothing can stand still in the universe or in the space. They are always moving. Even the sun and our solar system is going around the galaxy. So it's also, even though we say sun is at the center of solar system, but it's not stationary. In absolute space, it is not stationary. It's still going around the Milky Way. So, some more question. The length of the solar eclipse. The world record. So, as I said already, under West circumstances, the total solar eclipse could last as long as 7 minutes, 6.5 to 7 minutes, and that's also roughly the record. There's a question that Saturn has 83 moons, and can we see 83 eclipses on the Saturn? So remember, eclipses can vary depending on what is the size of the moon and how far it is from the planet, right? So if the moon is really small and it is far away, then you might see it transiting in front of the sun, but not really causing any the shadow on the planet. So again, the occurrence of the eclipse would also depend on in what plane these planets are revolving, or the moon are revolving around the planets compared to the orbit of the planet around the sun, right? And everything is not in the same plane. The moon's orbit around the planets can have a tilt with respect to the orbit of the planet with respect of the planet around the sun.
Yeah, so there are a few questions which are on the same topic, so I'll just club them together. So we're getting a feed from the terrace of our institution in Bangalore. So please stay back. You can see, now you can see it. Thanks, Prasanna, for getting that done. In Bangalore, the eclipse started only 10 minutes ago, and the maximum coverage of the sun in Bangalore would only be around 11%. And somebody's asked, why is it seen in Bangalore much after Ladakh? And that's a good question, because as the moon and the earth go around the sun, the shadow of the moon travels across the earth's surface, and it's traveling in the direction from north to south, right? So it started in Russia first, then Kazakhstan and Central Asia, and then it crossed Ladakh, and then it's now crossing Bangalore and South India, which is why you're seeing a time gradient in the way the eclipse is traveling. And in some of the eclipses, you would see that the direction of the shadow of the moon on the earth will be different, and therefore the order in which you would see the eclipse from various parts of the globe would also be different. There was a question about Saturn's. Did we talk about this amazing coincidence we have of this 400, the coincidence of 400?
Maybe you can tell a little bit about that.
Okay.
Yes.
So, right, people ask why we have a total solar eclipse occurring every now and then on the Earth, right? Now the question is, the moon covers the sun's disk exactly during a total solar eclipse, and you can ask why, right? It ends up being a very interesting coincidence that the moon is able to cover the sun's disk exactly now. The reason is because the sun is around 400 times as big as the moon, right? But the sun is not only 400 times bigger than the moon, it's also 400 times farther than the moon is from us, right? Because of that, the sun and the moon end up having the same angular size in the sky, which is why the moon can exactly hide the sun now. Now, this is merely a coincidence, and you can ask, this is a really strange coincidence to happen, is it natural and so on? It is, because the moon is moving away from the earth slowly, right? And therefore, the moon was much closer to us before, in which case it would have covered the sun much easier. But as the moon is moving away from the earth, after like a billion years or so, the moon will become much smaller than the sun as seen on the sky, and then you no longer have total solar eclipses. So we can only enjoy total solar eclipses on Earth for another few 100 million years. which is therefore we're lucky that we can, right? It's in some sense it's a coincidence, but it's a happy coincidence basically. There's another question saying, can the Earth block sunlight and cause the eclipse on Mars? In principle, maybe, but then the Earth's size is so small compared to the Sun's disk from Mars, like Banyal just said, that you would not be able to see it visually that easily. But then Ravindra Banyal here is also an expert on what we call extrasolar planets, right? Which are planets which we have discovered now to revolve around distant stars, nearby stars. And when you say eclipses, there is a very interesting and important connection between eclipses and discovering planets around other stars. So maybe you want to say something about that?
Yes. So as you see, we are watching the eclipse when moon is coming between the sun and the earth. Now, when we extend this idea to the stars outside our solar system, and of course, all those stars have planets around them. And now we know for sure that each star on an average has one or more than one planet. Now, as an observer, when we look at these stars, some of the stars and planets will have a right configuration close to the edge that as an observer, you will observe that a planet would cross the disk of the star. Well, you don't resolve planet and stars because they are so far away, the telescope cannot resolve. But by virtue of the fact that the planet passes in front of the stars, it would block certain light of the stars. And now we have instruments, photometers, which are sensitive enough to record that reduction in the intensity. And this is how one of the methods to detect exoplanet works, the transit method. Transit method is nothing but the eclipse caused by the planets around the other stars, which then is the reduction in intensity is recorded by the instruments that are on Earth or space-based instruments. And that's how we usually confirm or validate the presence of planet around other stars. There are other methods also to detect planet around other stars, but the transit method has been the most successful methods, where almost more than 70% of the total planet as of today are detected by transit method. Remember, today the confirmed discoveries are close to 5,200 and more than 3,500 are detected by transit methods. And
thank you. Now, Banyal has been sitting here with us since 4 o'clock explaining the eclipse to all of us. But I think it's time he went upstairs to see the eclipse for himself. So I'm going to relieve Banyal now. Quickly run out, see the eclipse yourself, have fun, come back.
Yes.
In the meantime, I'm going to ask Ramya and Aratrika to join us. A couple of questions which I think you would like to answer. One is that if you compare the age of the sun to that of the human age, what is the current age of the sun and how long does it take to become a white giant? I mean, I think they mean red giant, right? So basically, the sun's evolution. How old is the sun? What will happen to it? Piyali, Ramya, anybody wants to take that question?
So yeah, I will answer part of this question. So just like there is birth and death of human beings, the stars also are born and they die and fade off. But the time scale is quite large. We are talking about few billions of years time scale over here. So now the current age of the sun is about 4 billion years. It's already 4 billion years old, and it is what we call is in the main sequence stage. So what do we understand by main sequence? This means that the core, at the core of the sun, there is hydrogen fusion reaction going on, which means hydrogen is fusing to form helium. So that is the reaction which is currently happening, and that is the main sequence phase where the sun is going to spend most of its lifetime in the main sequence. So then once the core is completely converted into helium from hydrogen, so the sun will move on to slowly become the red giant, where it will expand, and this will take another few billions of years. And once the sun attains the red giant phase, I think that is when it will also engulf Earth and other planets in the solar system. After this stage, in a few billion years, we will end up, or the sun will end up as a white dwarf. It will shrink in size, and yeah, the fusion reactions at the core will kindly cease. So that's the phase. When compared to human life, which is only few 80 to 100 years old on an average, the sun will live on for about 8 to 10 billion years.
Ramya, you're muted. Okay. Thanks, Ramya. Piali, would you like to add something to that?
Yeah, I think Ramya has pretty much said everything. So I think the sun is basically in its middle age now. So maybe if the human lifespan is of the order of 80 years, the sun is probably 45 to 50 years old right now, which is what she said. So the sun will continue to shine this way for another 4 billion years before the catastrophic strikes. It becomes a red giant, and then the solar mass is not sufficient enough to form a neutron star or a black hole. So the end stage of the sun's life would be spent as a white dwarf, basically. So the sun is not going to end up as a supernova, but something much less spectacular than that. And after that nova is formed, the outer layers of the sun are shed, the sun will end up as a small white dwarf whose size is actually going to be much, much smaller than that of the Earth. So the Earth's size is around 12,000 kilometers. So the size of a white dwarf comparatively would be around 200 kilometers. So that is how the sun is going to end its life. But before it does, as Ramya pointed out, the sun is going to bulge up so much that it is going to the size of the sun is going to be similar to the orbit of the Mars. And afterwards it will shed its outer layers and end up as a very small white dwarf. So that is what I wanted to add.
Thank you.
Thank you, Niraj.
Thanks, Piali. Yeah. There's a question. Does eclipse have any effect on satellite communication? It's a good question. Not really, because the shadow of the moon is falling on the Earth, right? If the shadow of the moon was falling on the satellite, then of course its solar panels would not be able to generate energy for that time. So that would be the only effect. But there's another very interesting effect on the Earth because solar eclipses in our modern times when we focusing on green energy, right? So in many countries, a large fraction of their energy comes from solar panels. And if a solar eclipse happens in the middle of the day, for example, like it happened a couple of years ago, there'll be a sudden decrease of energy flowing into the national grid from the solar panels, and therefore they have to take special care to make sure that that doesn't have any adverse effect, doesn't trip the entire grid or something, right? So they have to slowly reduce the power from the solar grid into the national grid and then raise it again after the eclipse. So it's kind of an interesting effect solar eclipses have on our modern life in the context of green energies. There's a question about why can't Mercury or Venus have an eclipse on Earth? So we answered that earlier, but let's handle that again. Aratrika, would you like to handle that?
Yeah, of course. So the thing is that both Venus and Mercury, those are pretty small planets, and both are quite far away from us as compared to the Moon and Earth's relative size and distance. So the thing is, they do form shadows on Earth, but they are almost negligible. They cannot really be observed by us. So those are mostly called transits, not eclipses in that sense. Yeah, I hope that's enough.
Yeah, thanks a lot, Aratrika. Yeah. So we do have Mercury and Venus transits. There won't be any of them soon. We had a couple of Venus transits last decade and also a couple of Mercury transits. Nowadays we observe transits because they look beautiful. Like, the eclipse looks beautiful, so does the transit, of course. But the transits have a historical importance. It was by measuring the time of the Venus transit from different parts of the Earth that we first knew how to calculate the actual distance between objects in the solar system. So till then, we only knew the relative distances. We knew that, for example, if the distance between Earth and the Sun was 1, then Earth and Venus is so and so, Jupiter and Sun is so and so on. Everything was relative to a given distance. But to calculate the absolute distance between objects in the solar system, Venus transit was what was used in the 1800s to calculate them accurately. Now, of course, there are much more accurate ways of doing so. What is the effect of radiation skimming across the moon falling on the Earth? Not really. The radiation skimming across the moon falling on Earth is almost negligible. It would be because of gravitational lensing, and that's extremely small because the moon's mass is very small. Anyway, it would still be far less than without an eclipse, right? So there is no effect, there's no harmful effect of the eclipse on us. There's no extra radiation coming from the solar eclipse which will affect us. You can eat, you can drink, you can go out, you can do whatever you want to, and so on. It's an interesting question about the impact of the eclipse on the waves in the ocean. That's an interesting question. Of course, we know that waves on, I suppose you mean tides, so I'm going to assume you mean tides, right? Tides in our ocean are caused by the moon's gravity as well as sun's gravity, and we know that the moon plays a much more significant role in affecting the tides in our oceans compared to the sun. And of course, when the sun and the moon are roughly the same direction, the tides add up and you get stronger tides. And that is true for every new moon, for example, right? During a full moon, you get less tides because they're in opposite directions. So the tides during a new moon and during an actual solar eclipse aren't that different because the moon is almost the same direction as the sun within 2 degrees or so. So there will not be much noticeable effect on tides because of the eclipse, over and above what happens during a new moon anyway. So as you can see, the eclipse is ongoing in Bangalore, and that is because we're far south, and the shadow of the moon is moving southwards from Russia down to South India, and therefore, as time went by, we started with the eclipse in Russia, then Kazakhstan, Central Asia, Ladakh, Central India, and now and sun is set in Ladakh now, and now we are seeing the eclipse from Bangalore. In fact, we're seeing it from the terrace. There are Prasanna and other colleagues of us are upstairs sending us the live stream of the eclipse, which is being relayed by Swastik, who's here. I request Swastik to come here and say hello because he's been doing a lot of work, and I think people should see him and say hello. Swastik is a student here. He's doing his PhD in IIA, and that's it. And so he and Amit have been behind the computer since 4 o'clock, and it's because of them we'll be getting the live stream from across the world. So thanks. Swastik.
Yeah, hi everyone, and here I'm meeting. I'm still alive.
Yes. So as you can see, the sun sets in Bangalore at 5:55, but it will set probably a few minutes before that here because we have some trees and buildings in the horizon. It's 5:40 now, so we will continue this till sunset in Bangalore, and then we'll stop this transmission. We still have quite a few of people with us now. Thanks for staying so long. I will and Randeep Singh says hello, Swastika. I don't know if you know him.
Okay. Yeah, hi from my end.
Yeah. So somebody's asked whether shadow of the moon falling on the surface of the sun is called a solar eclipse. No. The light falling on the moon is because of the sun, and therefore the shadow of the moon will always be behind the moon as seen from the sun, and therefore it cannot fall on the sun. It's like saying shadow of me because the sun can fall on the sun, it can only fall below me, right? So that's how it is. Yeah. So there are some questions about how come ancient Indians were able to predict eclipses without telescopes and so on. That's a very good question. So astronomers from across the world in many cultures were able to predict eclipse very accurately much before telescopes were invented. And these were because they had good models for the motion of celestial objects around in the sky. So Indian astronomers, starting from Aryabhatta up to the Kerala School of Mathematics, and even later, if you look at Patani Samatha Chandrasekhara in Orissa, have had perfected or had continuously updated the methods of calculating the paths of the moon and the sun in the sky, and therefore the eclipses for many centuries. Similarly, it was also done, for example, in Europe, in China, in Mesopotamia, long back, in Egypt, and so on and so forth, in Greeks and all that. So the model they used was that they would model the objects going around the Earth in a circle. But that was not quite accurate because the Earth is the one which is going around the sun. Therefore, they had to modify these circles with what we call epicycles. And then they would look at the predictions of where the planets or the sun or moon should be, let's say next month, with what actually happened. And they would then notice there are some errors. They would then modify the epicyclic models and so on. So they kept modifying these models across many centuries, across various cultures, including India, so that it agreed better and better with the observations. But of course, once we realized globally that it was the sun that is the center of the solar system and not the Earth, then we threw away the epicyclic model and came to the heliocentric model, where of course the calculations became much easier. And now, because we can use dynamical equations from Newton's time, we can add in the effect of very small perturbations. For example, the effect of Jupiter on Earth's orbit, or effect of Saturn on Earth's orbit, and so on. And therefore, we can refine our predictions even more and predict eclipses much more accurately than we could before. But there's one very interesting application of ancient Indian eclipse observations, which is pioneered in Bangalore actually by Dr. B.S. Shailaja, who used to be the director of the Jawaharlal Nehru Planetarium in Bangalore, and her student Geeta Kaidala. They looked at stone inscriptions across Karnataka and Andhra dating 2,000 years ago, so last 1,000 years, in old Kannada. And some of them would be recording gifts by the kings and so on during an eclipse, right? And they would then mention, okay, this village, the eclipse was seen at this time, and this is when the king gave so much money to the temple, and so on. And this kind of thing is found in other parts of the world as well. So what people do, including Dr. Shailaja and a student in Bangalore, is that we know when the eclipse should have occurred and where should have occurred, let's say 800 years ago. You compare that with the records, and then you can check if there's any error. And any error can then be possibly attributed to perturbations in the moon's orbit itself. These are called delta T studies, and it's very important, right? So if you have eclipse records in stones or parchment or whatever dating back 1,000 years, 1,500 years, you can use that to have constraints on how much the moon's orbit has changed by very little bit. And this is something which is being done in India as well, increasingly, along with other records in other parts of the world. Are there going to be an impact of climate change on the eclipse? No, not really. If, except that, our atmosphere might get very, very hazy and murky and we will not be able to see anything, but that's no effect of climate change. I'm just holding the fort till people come back from upstairs after they see the eclipse. So I'll just keep answering questions till sunset. Are there any electric and magnetic field effects of the eclipse on Earth? No, there's not really. Not on the Earth's surface. Impact of eclipse on astrophysics in India? Oh, there's plenty. So eclipses are, as you're seeing, beautiful events, right? They're absolutely marvelous events, and there's something which excites everybody, right? So a lot of people I know got interested in science or astronomy because they saw an eclipse safely at some point, right? But astrophysics development in India itself was influenced very, very deeply by eclipses. The total solar eclipse on 18th August 1868 passed through Andhra Pradesh. Okay, and in Machlipatam, and then this just when spectroscopy had been invented, right? So Pierre Janssen had set up a camp in Guntur in Andhra, and Norman Watson, who was the director of the Madras Observatory, had set up a camp in Machlipatam in Andhra to see the eclipse, and in particular look at the spectrum of the corona and the chromosphere at totality. And he ended up discovering the element helium. during this eclipse in India. So that's a very important, Indian connection to solar eclipses, right? Do eclipses help the planet in any way or useful? No, they're not useful, but they're beautiful. And I think a lot of things can be beautiful and not really useful, and that's part of why things are beautiful, right? Yeah, so you can, so somebody asked about Varahamira and so on. So Aryabhatta had actually mentioned very clearly that eclipses are caused due to the shadows of the sun and of the earth and the moon falling on each other, okay? And he told you how to predict them. Varahamira and Bhaskara did not agree with him a little bit. Varahamira and Bhaskara invoked Rahu and Ketu. Aryabhatta did not. Much later, Lalacharya, who's another famous Indian astronomer, said the same thing. He said, look, eclipses are not caused because of demons and so on. That is a story, but eclipses are caused only because of shadows of the earth and moon falling on each other. And a lot of people in that age made fun of Lalla. Lalla was a very famous astronomer who lived, I think, 800 years ago in Gujarat, in present-day Gujarat. And people made fun of him, but he said, no, I can observe eclipses, I can understand how they cause, and he insisted that the stories you have about eclipses are stories, but we understand the science behind them, and it is because of shadows, and therefore they're perfectly harmless, right? So I would rather follow Aryabhatta and Lalla, personally. So Ravindra Banyal is back here. Do you want to tell us how the eclipse was upstairs? You can turn your video on.
Okay.
And tell us what you saw.
Yeah, so I had just gone out and saw the last part of the eclipse from Bangalore, and it was spectacular. We had like several students there and some visitors as well. So I would also urge people who are living in the southern state, and if they have a clear sky, they could probably step out and have the last glimpses of this eclipse, because the next one is going to happen maybe 2 years down the line. So this would be the last and the right opportunity to take the final glimpses of this year's eclipse that is visible from India. Right now, only from southern state. I'm sure most of the northern state, the sun has probably already set.
Yeah, and it's setting in Bangalore as well.
It's
I think it's set in Bangalore. The sun looked weird because part of it is covered by the buildings and the moon.
Yes.
There you can see the sun being swallowed up by some apartment complex, while it's also being swallowed up by the moon from the other side.
Yeah. Can you imagine now?
So we'll wait till the sun sets in Bangalore, and then we'll stop this live feed. This is the last view of the eclipse sun from Bangalore currently. It's already set in North India.
So there's a question.
And in Bangalore, the maximum is around 11%. So 11% of the sun's disk is covered by the moon. There we see the last remnants of the sun. And I also want to introduce you to Amit, who's been behind the computer along with Swastik, bringing us a live stream from 3 different places in India and 2 abroad. So that's Amit. Say hello.
Hey guys, nice to be here and be a part of all this.
So now we see that the sun is set. Yeah. If you're at the apartment complex there, you will still see the sun eclipse, but then they're hiding it from us. So last words, Banyal.
Yeah, so I just want to say that these solar eclipses, they are natural phenomena, and they are not harmful, neither they are anyway auspicious. They are beautiful, as Neeraj has said, and we should not deprive ourselves from these wonderful spectacles that happens once in a while in the cosmos. So please go out and enjoy, and encourage others also to take part in these things.
Well, the sky is beautiful in the daytime and at night time. So go look up. Contrary to what Netflix documentary's name was, at night go look at the sky. If you're in a big city, of course you can't see many stars. But if you're in a small town, then you have the entire sky for you. The beautiful Milky Way, the planets which move every day. Go to the nearest planetarium or science center, find out more about astronomy. They will have telescopes there to show you stuff at night time. Go online, look up the lovely videos explaining basic astronomy on YouTube. There'll be amateur astronomy clubs in almost every town and city in India. So find out the nearest amateur astronomy club, join them. And before we say bye, Piyali and Aratrika, would you like to say anything?
Yeah, so I could also catch a glimpse of the eclipse while on this NH48, but I could not watch it at the maximum thing because it is already now below the horizon. But while it lasted, it was really wonderful. And the sky was totally clear here.
Yeah. Thanks, Piyali. Thanks for joining us from NH44. Aratrika, any last words?
Yeah, I would like to see the results of the eclipse hitting hashtag that we posted. Yeah, after this, check that out.
Thank you. Thanks, everybody. So I would also like to thank a whole bunch of IIA staff who have been with us preparing for this live stream for many weeks now, from Leh and Hanle, Ladakh to Kodaikanal to Bangalore to everywhere, and as well as all our students who've been preparing these wonderful videos about eclipses in 12 different Indian languages, created posters, and helped us have this wonderful awareness campaign, which has brought all of you here for the last 2.5 hours. So thanks again, everybody, for staying with us on YouTube. And we'll meet you at the next celestial event. So meanwhile, look up at the skies, look at the stars, and have fun with the sun. Goodbye.